All right, welcome everybody. So in this video, we are going to get an introduction to what a Markov chain is and take a look at some examples of where Markov chains may have some useful applications. So to get things going, let's motivate Markov chains with an example. So let's imagine you would like to predict the weather. And there are only two possible states. Either it's sunny outside or it's rainy outside. And we'll see that this process can easily be adjusted to account for more than more than two possible states. But for now, to set up a simple model, we're going to assume just two states, sunny and rainy. And we can always observe what the current weather state is. So I can walk outside and take a look at whether it is raining or not. And we also know that the current weather has some bearing on the next day's weather. So, for example, in this model, let's assume that if it is sunny out today, then there's a 90% chance that it's going to be sunny tomorrow and a 10% chance that it's going to rain tomorrow. Whereas if it's raining today, let's imagine that there's a 50% chance that it's going to rain tomorrow and another 50% chance that it won't rain tomorrow and the weather is going to be sunny. So what we know are there are two possible states in this mathematical system here that we'd like to model, and we know the probabilities of going from one state to the next, from one day to the next. And based on this information, we'd like to know, can we predict the weather for tomorrow? So let's take a look at how we might be able to do this. So we can take all of these probabilities that we were given and we can set up what is called a transition matrix. So this is what the transition matrix would look like for this example. And so first, let's denote sunny as state number 1 and rainy as state number 2. And it doesn't matter which way we number these states. So let's take a look at how we can come up with the entries in this matrix. So for example, let's take a look at entry P21. So this is the entry in the second row, first column. So this is going to tell me the probability of transitioning from state J, state 1, so going from sunny to state I, which in this case is 2. So this is going to be the probability of transitioning from state 1, which is sunny, to state I, state 2, which is rainy. And we're told that going from sunny to rainy, that is 10%. So this 0.1 is coming from these odds here of going from 1 to 2. And so as a result of these being probabilities and us needing to exhaust all possible outcomes, namely if it's sunny today, then the probability of it being sunny tomorrow plus the probability of it being rainy tomorrow must add up to 1, since that must account for 100% of the outcomes. So note each of these columns in the matrix adds up to 1. So we call these columns probability vectors. And a matrix which satisfies this condition that every column in the matrix is a probability vector, the entries add up to 1, then we call such a matrix a stochastic matrix. And these have lots of applications in probability, statistics, machine learning, and so on.